Good morning, good evening. Welcome to the lecture number 26, pre-lecture by Professor Raghuram from IIIT Kanchipuram. He's going to talk about design of innovative high-volume throughput machines for extracting value-added products from agricultural waste. Dr. Raghuram is currently working as a faculty at the School of Interdisciplinary Design and Innovation at Indian Institute of Information Technology, Design and Manufacturing, Kanchipuram. Previously, he worked as an impact specialist on the composite fan and ultra fan programs at the Civil Aerospace Structural Systems Division at Rolls-Royce, UK for about 8 years. He joined Rolls-Royce immediately after completing his postdoctoral research at the School of Mechanical Engineering, University of Leeds, UK for about 4 years. He completed his PhD from Center for Product Design and Manufacturing at IISc Bangalore and BE and ME from PSG College. He has worked in various disciplines, mainly focusing on the development of advanced experimental and numerical simulation tools for product safety under impact and crash loads. However, his current research lies in the application of design thinking for sustainability, the transformation of agricultural waste into wealth. He has published over 20 papers in 25 journals, 25 conference papers, and 20 technical reports and 2 book chapters. We are looking forward to your talk. I think it's an intriguing topic. With that, I will hand it over to you, Dr. Raghuram.
Thank you, Dr. Subramanian. So I'll start my presentation. So I'll share my screen.
Yes, please.
Yeah, so very good morning and good evening to all of you. So myself, Dr. Raghuram, so currently working as assistant professor and head of the department of School of Interdisciplinary Design and Innovation. So and my today's topic, so broadly explaining about how the agricultural waste can be converted into an useful product. So through developing an innovative machine for extracting the banana fiber. So just this is our campus, bird's eye view. We can see we have a very beautiful campus at the heart of Chennai, which is Indian Institute of Information Technology, Design and Manufacturing. And then, so this is an Institute of National Importance established in 2007 by the Ministry of Education, Government of India, to pursue design and manufacturing oriented engineering education and research, and also to promote the competitive edge of Indian products in the global market. So we offer BTech, MTech, dual degree and PhD programs under 4 different departments: computer engineering, ECE, mechanical, then School of Interdisciplinary Design and Innovation. So with these backgrounds, I should start my today's topic, which is design thinking. Just an introduction. So, which you all are aware of it. The design thinking is an iterative process to solve the complex problems and so creating new ideas. So this consists of 6 different steps. So understand and observe the problem, then give what is the point of view, and then ideate, prototype and testing. So this process is extensively followed. The examples which I have taken to demonstrate the design thinking process. So design thinking means creating innovation by combining multidisciplinary teams in a creative space and is an iterative approach. So if you see, in other words, so this is an innovation where we need the breadth and depth of the subject matters, where multidisciplinary teams are involved, and also it allows the others to participate in the creating or innovating things. Even very anonymously or unknown people can also provide their inputs to create something. And then, so it consists of 2 space. One is problem space, other one is a solution space. So where we need to spend more time on understanding the problem and observe things. and where that empathy is playing a major role. That's called problem definition space. And then creation or ideation, prototyping, and validation is coming like in solution space. So to see, this is the techniques which we use during the initial phase, during empathy phase. So we feel like the problem is happening to us, and how, so see what is the go for a pair of interviews and notes taking, then see through the eyes, so how they are feeling, and we'll go for an open-ended questions. So these are the some of the techniques we use to identify the problem and create a problem statement. And so with that, so my first observation is India is a fourth country in terms of banana exports, and India is cultivating more of bananas as one of the main source in the agricultural sector. And currently, bananas are cultivated about 8,30,500 hectares, especially in India. In that, the pioneering states are Tamil Nadu and Maharashtra, followed by then Andhra, Telangana. There are 5, 6 states. Entire South India is fully of banana cultivation. So if you take in Tamil Nadu alone, because where our institute is located, in the surroundings, so there are around 2.15 lakh acres, that means 0.2 million acres are used to cultivate banana. So after harvesting banana, so this is the banana will be harvested at this pendule portion, and then this entire remaining stem will be lying in the field. So each acre consists of around 1,000 to 1,500 trees. So 1,500 trees are only mother plants. It will have child plants also like this, the multiple child plants. So this entire banana cultivation area will have enormous amount of raw material, which is currently is being taken out and put it in the roads, fill it in the lakes, and it lies everywhere. So farmers are struggling to dispose, because that much area is required for them to dispose for so before the next cultivation is going to happen. So one is a farmer's problem, and secondly, it is a biodegradable and sustainable. So they will not they will put it as it is. It will take its own time for degradation. So it's that is a major issues right now the entire farmers are facing. So now then I thought how we can help the farmers. So there's a clear understanding of the problem, and then how we can convert that waste into a useful product. So that's the entire observation. And if you look at the use of the banana stem after removing this banana, and this entire stem has got multiple use in the applications like handicraft products. Okay, so you can extract fibers from this, and you can use that fibers to make handicraft products, bags, even shirts, then saris. So like that, there are multiple products I can make. And this pendule, even the inner core of this banana stem can be used to make some food products. And then some of these, while extracting the fiber, there are some material pith and also structure waste that can be used to make the structural composites for interior components of car. So there are multiple applications already is been used by many years, and but it's not extensively. The complete utilization of the waste available in the country is not properly utilized because of it is done in the small scale right now. So in the small scale, how they are doing it, how they are extracting the fiber. So the banana stem consists of several products. So this is the banana stem. After harvesting, it can be brought into a farm to the common place. From there, they will be splitting into two halves or 4 quarters, and they'll be using a manual labor to remove the seeds from that stem and the inner core, and then manually they will put it in this machine one by one to convert that into a fiber. While extracting fiber, the lot of waste will be collected. That's away from the squeezing of that waste will give some water. So this water is called sap. That sap also has got some applications like conversion of sap into an fertilizer, biofertilizer. Even you can extract bioethanol, and you can use this as a nutrient element because it has got up to 20% NPK, especially potassium is available in the water. And then the fibers are dried. These dried fibers are is used for making these type of products. Okay, so this is my observation. So this is a full chain of the process. Since it is a manual process, they are not, this machine can give only 10 to 15 kg of fiber per day, dry fiber per day, per machine. So this process is very tedious, time consuming, and a lot of manpower is involved. Okay, so to avoid such kind of things, we need a sophisticated or highly automated system to handle the entire waste which is available in the country. Okay, so then in the definition space, after understanding the problem, in this definition states we use storytelling, clustering, then plus task flow analysis or framework. So used such kind of two-way diagrams to understand the strengths, weakness, and its opportunities. And then also, during the ideations, we gathered a team. So we had around 15 members team to debate the problems and understanding the existing issues and how we can put it together into a new concepts. So all that we have done by following this process, and then during that analysis ideation, before doing the analysis, we did a cost benefit analysis, and also the what is the product outcome, how we can convert that product into useful products. Okay, so if you consider the each banana stem is around 45 kg. Okay, so the stem has got sculpture waste, which is a pith material like a cocoa pith, so that is around 30%. So in that we will get around 14 kg of sculpture waste. And the sap is a water which is around 60 to 70%. In some stems it will give 70% also. That water is around 27 kg in that. And the inner core, so but that is edible part of the stem, that inner core is around 8 to 10%, and the fiber is only 1%. While extracting fiber, you will get all the other three products. So that is this system of this. So these fibers, the central core can be used for making pickle, candy, soft drinks. These soft drinks are like a pharma products. These soft drinks can be used for treating patients with kidney stone. So kidney stone removal will take place for that. This inner core juice can be used, and then for diabetic. So it's a good. It will provide good control of glucose in the body. So that's a glucose that diabetic treatment also this drink can be used. And the fiber, this 1% fiber, which is around 400 grams, that is fiber can be used in the textile industry for making clothes and garments, and we can make so cellulosic fibers, and also we can make these composites for structural applications. The currency notes we can make. The first currency of Japanese currency was made using banana fiber in the 13th century. Okay, so currency notes can be made, and then we can make handicraft products. So the fiber has got some applications, a huge amount applications. And the waste materials, one is a sap and the sculpture, that these together is around 90%. The sap is used for making mordants, is using like a dye in the textile industries, and also we can make organic liquid fertilizers because it contains around 20% of potassium. And the sculpture is the pith that can be, currently it is being used as a composites and vermicompost. And actually through this process, I have developed sustainable packaging materials for food grade applications. And also I have made some acoustic panels using this sculpture waste. And with that, so I have come up with the concepts ideas where these machines can be used for 24 hours, and six pillar machines with 8 seconds processing time. We can approximately process around 6,500 stems in 3 shifts, and that will give around 3 tons of fibers. So in the manual machine, we can get only 15 kg of fiber per day. Through this proposed concepts, we can get up to 3 tons of fiber. And then similarly, we can get the so we were getting 3 tons of fibers. So we'll get the fiber of around 68 rupees in Indian rupees per kg. So when we produce that much quantity per day using our proposed concepts, and then we have the other quantities. Only fiber is only the 1%, 1 or 2%, but the remaining quantity are like sap is around 1 lakh 50 to 75,000 liters sap we will get, and then 90 tons of structure waste, and 24 tons of inner core. So these quantities can be sold in the market as it is, or we can convert into another value added products, and that cost will be maximized by doing value additions from one waste to the other. Okay, so when you process sell all the sap, structure, and inner core produced through this system, then finally you will get the cost of the fiber is you'll gain around 250 rupees along with 50,000 along with the fibers. Okay, so this will give each machine will give around 7.5 lakh rupees per day through value additions without further processing, just using this machine to extract these 4 different products. Then I did the cost analysis, and finally it worked out to process around 40,000 metric tons of fiber. We need around 50 units of the machine, and that will give us around over 1,000 crores, means more million dollars, million rupees, plus 50,000 metric tons of raw fibers. So this cost analysis I have done to understand the entire the business of this system. So this is how, along with my students team, we have come up with a concepts idea where this is called the fiber extractor, and this is the sheet peeler machine, where the stems will be fed through this sheet peeler. Then here the sheets will be removed, removed from here, and the inner core will be separated. Okay, so then all the sheets will be collected. So there are 6 peeler machines shown here. The sheets will be collected in a big conveyor, and that will feed automatically into this extractor unit. So from this extractor unit, we will get the fiber at this end. So through the bottom conveyor. And this is the concept I wanted to show here. So this is the virtual plant which I have come up with to set up a factory, and here all these banana peeler machines will be placed. So this is this entire unit. So likewise 50 units, are placed. Which consists of 6 peeler machines and 1 decorticator machine and 1 fiber collection unit. And this is the stage 1, so where the stem will be loaded. This is the banana stem is loaded, and there's a gate. The gate will open, and this stem will roll and placed in between the rollers. So these are the support. So that is how the roller will provide a support to the stem, and the stem will give the rotation. So the conveyor gives the rotation to the stem, and the sheets will be separated from that, and the inner core will be ejected here. So this is the inner core, and the inner core will be collected through another conveyor for further processing. And here all the sheets are collected, and multiple sheets will be fed into this decorticator machine. So in the manual machine, only one sheet at a time can be fed into the machine. by manual methods, so by human using manual labors. So here the automatically seeds will be entering into the decorticator, and the fibers are beaten up here, and the structure will be collected at the bottom of this conveyor and back side of this conveyor, and the fiber will be collected here. So this is the concept which we proposed to the investor. So these are developed by our students. Okay, and this is the virtual plant where one single raw material, that's a banana stem, will enter here, and that will go into these processing units which I have shown now, and then the fiber will be collected here. The fiber processing will be done here, and then it goes for composites manufacturing unit and also the textile processing unit. So from here you will get fiber. So here you will collect the fibers, and the fiber will be sent for the textile applications. Okay, and the water which comes from this stem or will be collected through the underground tank, and then process it here, and that will give us the processing unit here where we'll make the biofertilizers. Okay, and then the the inner core will be collected here. The inner core will be further processed. The pharma products can be developed here, and then that will go into another applications. And then the structure waste will be collected here. The structure is processed and made like a compost or vermicompost or any other products that will go in a different applications. And finally, the waste which is created, the entire waste in the all these plants will be collected here, and that is converted into a bioethanol. That bioethanol is will be used for from that we'll get the bio gas. That gas will be used to run the power plant. So this is the entire business model. The plant I have proposed virtual. This is a virtual plant for establishing this business. And then the next one is prototyping phase. So we have several techniques of making prototypes. One is physical wireframes, infraction, and storyboards, acting, and prototyping. So I have chosen the physical prototypes. That is a technique. So you can see the Lego-based physical prototype. That's your usual technique. So this is how the prototype was made. I can show here. This is the entire banana fiber banana cultivation area. The overview of the this is our entire team. So this is how we have generated all the concepts and the prototyping fabrication work. It's me carrying the banana stems from the field for the trials. This is how the stems were brought and tested in the factory. So this is that manual peeling is now made as a automated peeling through this concept, the prototype ideas. So several iterations you have done, so multiple changes. So that is where the design thinking concept has been adopted. So this brought it to our laboratory, from the factory to our lab. So this is the decorticator, which is unique, and it has got multiple blades, and the speed at which it beats is also very high, around 1400 RPM. So this is the multiple sheets are fed.
While you're showing this, I have a question to ask you. You have a lot of very sharp instruments in terms of blades and feeding and so on.
Yes,
Uh,
sir.
how do you pay attention to safety issues here, right? People could get their
Yeah,
hands.
I'll show you.
Yeah.
This is just a fabrication, so we have covers for all of them. This is
Oh,
how it is covered. You can't touch any of those parts during the operation.
oh, okay.
So this is, I'm showing how the fabrication is done.
Hmm.
Yeah, and brought to the lab.
Where do you do it? With a professional company and the students work there too?
Yeah, yeah, the students were attached to the professional company. We
Mm,
provided the drawings for our drawings. They have made the
mm,
prototype. Yeah. So finally, so everything has been covered, and it will be operated from the outside of the machine. So
mhm,
nobody is allowed to go near to the machine during the operation.
mhm,
So this is how the concept, this is the stems which will be placed here. And right now we have attached some other components also.
mm,
So no human intervention in the process.
mm,
Yeah. And then these are different prototyping so skills. So and then how I addressed some of the solutions problems. So for example, here initially we did not have any supporting rollers,
mm,
just we have the blade. So then we did some failure mode and effect analysis to overcome such kind of an issues. So we have done the calculations like here we saw how by analyzing the video there what are the issues. So one is the blade angle, then frame of reference, then stem trajectory and blade trajectory. So all that matters a lot for effective peeling of the sheets from the stem. So then we did the analysis of individual components by analyzing the video which is taken from the stem, and then we have brought all things together, and then so this is the FMEA we have performed. Finally we come up with the supporting rollers and then ejection systems. Everything has been incorporated right now. So this machine has been built for commercial use now.
mm,
This is the peeler machine where the sheets are peeled continuously without any human intervention through this supporting rollers and the conveyor system.
mm,
So this is where that inner core is reached. So that will be ejected from there through this ejection system. So where this can be collected from another conveyor to further processing. So the fiber will get only from the sheets which we are removing from the stem. So this is the before implementation of this roller system, and then I can show some videos after the implementation. So this is how automatically the sheets will come from there. The individual sheets, it will come and connect with the another conveyor for transferring the sheets to the decorticator machine. Okay, so then this design thinking process. So finally, we have got this system like this. So here, yeah, I will show you the trials. Yeah, so this is a unit we have. We have a cutting machine. From there, the cutting machine will cut the stems at a required size, and then that stems will be fed into the seed peeler, and the peeler will remove the seeds and give it as an input to the decorticator by converting into 90 degrees. The seed peeler will give the seeds from come here. The batch will be filled here. So this conveyor system will push to this decorticator. There we will collect the fiber beating will takes place. The fiber will be collected at the bottom. That will goes to the cleaning system, where we will do the squeezing and water washing, and then finally fiber drying. So this is a trial video which I can show you how we have taken the trials from this machine, and from where we collect all the outputs. So the stem will be loaded on the back side of this machine. So from there, it will give you the sheets continuously, and through this conveyor, it will come to this transfer system. It will transfer the sheets from this conveyor to this conveyor at 90 degrees, and that will go into this unit. That's where the decorticator processing is taking place, and the fiber will be collected at the bottom, and the fiber will come and fall on the other end to the another conveyor. So this is the entire chain of this process. So everything is automated. So here during the trial, since some corrections we are taking place, so I am there. I am standing there to correct it. But currently, this system is fully automated. No one is intervened in between, and it is placed in the factory for production. So this is the fibers which we collect from here, and this is the structure waste, and this is sap water. Now during trial we have collected manually, and finally, so this is our team along with Padmashri Dr. Mailsamy Annadure, who is an expert, is known for Chandrayaan 1 and 2, and he's called as India's moon man. And so with his leadership, we have done this work, and currently, so we have made a production version of this unit and placed in the factory in Mumbai. There is a company called Gencrest is currently using it, and this machine can produce up to 3 tons of fiber. Nowhere in the world this type of machine is available. Even we have visited in China, they are not able to get the machine. They have some machine, but they are not able to get the textile grade fibers. Our machine only can able to produce textile grade fibers, because our beating drum design is in such a way that it will give the textile grade fibers. And I have filed around 10 Indian patents. So 3 of them got granted last week. So there are a couple of another 7 patents are in the process. So that we will get those patents also will be granted maybe soon. And so this system is very unique, and this going to address or handle the entire waste which is available in the country. We can make 100 units of this. That will give a big business for the business people. So over 1,000 crores of rupees per year as per the estimate. But the sustainable packaging materials, making organic liquid fertilizers and pharma products. So those will give further revenue. So this business can go up to 10,000 crores revenue per annum. So that's a business for all to happen, to make it happen. This business, we need this machine. So this machine is the heart of the entire business. With that, I say thank you for giving the opportunity to share my experience on how to convert this waste into a wealth products through developing an innovative high volume throughput machines. So with that, I say thank you to all the listeners and team for giving the opportunity.
Thank you very much, Dr. Raghuram. It's really quite a fascinating experience you have produced of starting from a particular processing which is done by hand today to transform it into an automated system and scaling it. And not only that, I think there are other ways you could potentially uh, promote this idea, because if it can be used for creating packaging instead of plastic and
Yes.
other forms of substitution, there might be a whole set of market from the fiber point of
Yeah.
view to build up. So there might be, and also the amount of fuel and waste you're saving, you could calculate in terms of sustainability, in terms of amount of carbon dioxide reduced, etc., to give a whole picture of the
Yes, sir.
potential impact from a sustainability and environment point of view. And
Yeah.
the other question
Yeah,
I
three
have,
of my
yeah,
PhD students are working in that direction. So one of my students is working on developing the sustainable packaging material where we can use this as a substitution with the thermoplastics.
yeah,
And
okay,
so I'm collaborating with Fraunhofer in Germany.
uh-huh,
So to develop some vegetable crates, so then some 50% of thermoplastic with 50% of this waste,
mm-hmm,
uh, mixing together to develop an concepts means vegetable crates. So that's one opportunity we are working with the Fraunhofer University.
mm,
And then other areas like if you take the entire stem, the top portion is the leafy portion. So
yes,
leafy portion will not have any fiber. The
right,
bottom portion also will not have any fiber.
right,
So we have to use only the middle portion.
yeah,
So the top and bottom portion are put it crushed, and that is used. That is converted into a bioethanol.
oh, okay,
So
yeah,
that's what every entire from a single waste, we are not wasting anything.
mm-hmm,
One waste can become a
it's,
raw material for the another product.
that's
If
right.
any waste is coming out of that processing, that is used for another process, another value added products. Like that, we have identified around 39 products.
I mean, I was just imagining its impact, for example, in Latin American countries and Hawaii, which produce a huge amount of banana plant, bananas
Yes, sir.
from the Western world, Anyway, I have more questions. I'll ask others to ask a question. Uh,
Yeah.
Okay, can I ask a question?
sure, please.
Thank you, Professor Raghuram. It's a very interesting and very promising technology that you have developed. I'm Shyam Sundar, by the way. And I have a whole bunch of short questions, actually. But let me start. Can you give us some idea of economics of this technology? That is, for processing, let's say 10 or 100 hectares of waste from 100 hectares of banana plantation, how much investment is needed, how much labor is needed, what's the cost of it, and what is the value of the products that you mentioned and what will be the net surplus generated by this processing from, let's say, 100-hectare area. I want to just get a rough idea, approximate idea of the economics of this.
So this is the cost analysis which I've done. So if you see here, if I want to produce 3 tons of fiber per day, using the machine which I have developed, okay, the total expenditure is only 2 lakhs per day, and per cost of value added products, as it is, if I'm so considering there are 4 outputs from this machine. Number 1, fiber. Number 2, sap. And number 3, inner core. And number 4 is a sculpture. These are the 4 outputs from this machine. Okay. If I am not doing any further value addition, if I am selling the sap as it is, like for 2 rupees per liter or 5 rupees per liter, or 50 paise or 1 rupee per kg of inner core and the sculpture. So if I do the calculations, value addition will give me some around 7.5 lakh rupees per day per unit. Okay. And in the if I calculate the entire year, it will be around 20 crores, and will get 1,000 metric tons of raw fiber. And so my cost will be around per year per
Your
machine.
expenditure includes equipment and labor,
Labor, everything.
average per day.
Yeah, everything. So this will give around, for 50 units will give around 1,000 crores. So here I am extracting only fiber and supplying as a raw material for another processing. If I extend this business, if I want to convert that sap which I'm getting from here, instead of selling it for 2 rupees, if I further process it, like convert into a biofertilizer, the conversion cost is only 20 rupees per liter, but my selling price is 500 rupees per liter. So the 480 rupees is a profit per liter, okay, in one machine, or one liter processing of sap. So in my machine, when I am processing this for 3 tons of fiber, if I want to get, I will get around 1.5 lakh liters of sap. So 1.5 lakh liters into 500 rupees. That is the cost of the selling price of the sap alone. Okay.
So this is this
I have a multiple business out of this. So I need to the exact numbers I need to calculate and give you. So I'll take your email address. Probably I will share that the cost calculation with you for 100 hectares.
Okay. And includes transportation, possibly refrigeration, and storage of these materials,
No,
etc.
that is not required. Actually, for sap we can continuous production we can make. So once the sap is extracted from this machine, that we can take it to immediate processing and use we need only the digester system. So we'll put that we have the technology. We'll put it in the digester system for 11 days, and then it will go to the filtering. After filtering, it will go into packing. The packing is our continuous, so it will all go through a single chain. Likewise, we have multiple chains for each of these 4 products can be converted into multiple products. So that cost calculation I will provide you.
And does the operation of this factory be seasonal, or will it be continuous throughout 12 months of the year?
Continuous throughout the year. So because we'll get the banana stem available throughout the year.
Okay.
Yeah. So especially in Tamil Nadu is around 2.5 lakh acres are used, around 2.5 lakh acres are used for banana cultivation. In Maharashtra, it's around 5 lakh acres. So you will get the stems round the year.
And banana stems will have to be bought from the farmers because they will soon find out that you are making money from it. So they will want a part of the money, right?
Even then, even if you get the stem for 10 rupees to 100 rupees, our profit will be very high. That
Nice.
for them, it's like almost like a nil what we pay from the revenue which we generate from here.
Okay. Thank you.
Any other
Currently, I'm
questions?
working on to develop this system like a mobile system, which can be loaded into the truck. Truck can go to the field so that you can process it there only and collect the output from there. So likewise, I'm designing right now. So possibly that will be a even better business model.
Nice.
So right now, our India, Maharashtra government has given around 60 acres of land to set up this factory to the company. They have set up the plant. Right now, it's in the running condition. So it's been 1 year before they have started this factory.
For different varieties and types of bananas,
Actually, the
stem.
types of bananas, red banana. So there are certain varieties will give you good amount of fiber. Okay,
What
so
I'm
for
asking is that the
Grand 9 was originated from Philippines. Grand 9 has got good amount of fiber, and then red banana, then Nendram. There are around 20 varieties of bananas available in the country, in which at least 6 or 7 varieties are very good. It has got very good fiber content, and also it's a very high strength fibers. So the remaining things we can use it for only extracting sap and other structure material instead of fiber. That sap we can convert it into a fertilizer. So everything we can use it. So whether it's in
So,
this case, fiber is not a big business. In this case, sap is a big business because that is around 70% in each stem, and that gives that process is very simple, and that only gives the more value means revenue to the company.
so I was thinking it's a side issue. You said that some of the bananas, the fiber is not good, sap is the main thing. I was wondering whether you could use that fiber infused with something for some kind of packaging material. You see, use
Yeah, we
the
can
poor
try.
quality fiber like reinforcement to
Yeah,
some other
that's what we are trying.
material
That's what we are trying.
like some carbohydrate with these fibers can produce cups and reusable things from that too, right?
Yeah, so I will show you one product. Are you able to see the product?
Yeah.
Yeah, this is like a coffee cup made from the banana, so means stem waste. So the whatever you were saying, no, that we have used in the compression molding, we have made.
Yes.
Yeah.
Yeah, go ahead.
So this cup we have made using that waste. So whatever you are referring to,
Oh,
and
okay.
also we have made the storage box.
Mm-hmm.
So this storage box we can
So
make use.
what are you using it to hold it together? What material?
This it's with a high temperature we have crushed. That itself has got some bonding
Okay,
property.
bonding
We
problem.
don't need to use anything else. So just it's compression molding.
Oh, okay. There is no bonding.
No, yeah, no bonding.
That's really fascinating. Yeah.
Yeah. So there is no additional material used for bonding. So because of the heat, it has bonded
Yeah,
together.
yeah, I understand. Yeah.
Right now, this strength we need to check because we may need some bonding material to, because now we can break this and
Mm.
reuse it.
Mm-hmm.
Even we can give this to cow. The cow can eat now. So you can dispose in the environment. Pollution will not be there.
Mm-hmm.
So they are
Can
completely.
it be used to make?
Sir?
Can it be used to make paper?
Yeah, we're making papers also. There's some files also we have made. Folders. So that folders we are making it.
Mm.
The papers easily we can make.
So what is the quality of the paper? Is it quite good?
The
Should be
quality
quite
will
a
be not
strong
writing
paper,
papers.
right?
Not writing papers. We make this type of folders.
Oh, okay.
Something like this folders we make.
Uh-huh. So you are able to print on it too.
Yeah. So we can print and we are right now, so many folders are made in Maharashtra. They are selling it right now. It's available in the market.
Yeah, it's quite
The way
fascinating what you have done. Really, congratulations on taking an idea. And I think one of the things that comes out to me, I'm a fan of Edison. All his life, he always went to look for places where the work was drudgery and dangerous and things like that, and when try to automate them. And I think here you have shown that there is something which is a waste, even though it is done in a small scale, and it's really drudgery work in terms of what you can do and transform uh, an existing resource into a huge resource base for a variety of products. And I think this is an example of how we can actually look at agricultural products of different kinds. I'm sure you can make cups or fibers out of even rice fields and corn fields, and look at them as a way to produce a whole class of
a lot of
degradable
potential.
and reusable products.
Yeah, so we
Actually,
have made some of other products also.
Hmm.
So this one, this box is made from the sugarcane waste after the crushing.
Ah, okay.
You see the
Because there's a
sugarcane.
lot of fiber there too.
Yeah. The color itself different because it has got a lot of that binding property, no glucose.
Uh-huh.
Sugar has contained
Yeah.
some binding property, so this is stronger than that one.
Mm-hmm.
So that's why currently we are looking for some bioresin also, so that we can reduce the thickness, and we can make completely, we can go for means but the degradable products. So we can remove the thermoplastics.
Mm-hmm.
It is for packing applications. We can use this.
Mm-hmm.
Yeah, this is made of a sugarcane waste.
uh, fields, sugarcane.
Yeah. After means extracting the sugarcane juice, that waste is something like this, right? So after extracting the sugarcane, means
Yeah, yeah, go ahead.
yeah. So this is the sugarcane waste. This I have used a pulverizer to make it like a powder and form that one. Now I'm going to use this one along with banana fiber for making some more products, structural products.
So
And this
are
one
they complementary structurally?
that I'm trying now.
Mm-hmm.
So I have to do some testing and all. Now I'm doing some samples making, but this one is 100% this only this product. This storage box was
Mm-hmm.
made only using
Mm-hmm.
Professor Ram, may I mention, I'm sure you're familiar with papyrus used in Egypt. And
oh,
Egyptians use papyrus plants, the stem of the papyrus, to make paper with the layers.
yeah.
And that paper was used for writings in the Egyptian tombs. And that papyrus is so strong, even 4,000-year-old papyrus is still there in the tombs. And I mean, it's vegetable, of course, and I'm sure you're familiar with it. If not, you might look it up.
Yes, sir. Yes.
What is interesting to me is this, that in some ways we don't grow enough pine for paper. We actually import paper a lot in India, I believe. Right? If we can start using agricultural fiber waste as a way to create new forms of paper, that would be a great advance. Of course, different quality papers, depending upon the fiber you use, you could potentially make those things as well. So the potential is really large, just beyond banana, like you have chosen sugarcane, right? You can also look at other trees and plants where the fiber content of the
Yeah. So, yeah. So there are some of our students doing their projects and using varieties of wastes and agricultural waste to make such products. So around 10 or 15 products were made, and we have used even rice husk also making the storage boxes and the coffee cups. And also we have used means coffee bean waste for making this type of coffee cups. So those kind of so there are variety of waste we are taking and trying to convert into products. So our students are working on it.
Well, sugarcane waste is used by sugar mills as fuel.
Yeah.
And you'll have to convince the sugar mills that they can get
And
more.
actually, there are the sugar mills are few sugar mills are available, but there are a lot of small scale industries
Yes.
who make all jaggeries, jaggery and this like
Yeah.
powdered jaggeries, you know. So those
Yes.
companies, if I look at my in Tamil Nadu state where I'm located, near Namakkal, around 250 to 500 small factories are there. So right now they are not using it for burning applications. So there that waste is now lying in the field only after extracting sugarcane juice. So
Mm.
that I want to mix with another product and clean this entire area so that farmers will be so happy, and that waste will be completely processed. So
Mhm.
likewise, there are so many places, so many other wastes also there. We can mix along with that. For example, so many agricultural residues, so other products, like when you are cultivating dal, grain grams, whatever, after taking the useful product, the remaining waste can be converted into powder, and that powder can be used for making this type of packaging products.
Mhm.
Doesn't matter which residue it is, any agricultural waste we can take and process it. That's my overall
Yeah, because
objective.
all of them have basically a different ratio of fibers and cellulose, right?
Yeah.
And
Mhm.
Yeah.
you are just extracting them and reusing them, just as you
Mm.
produce viscose fibers before, right?
Yeah.
Mhm.
Very interesting. Thank you.
Thank you very much. Sudhir or anybody else, you have a question? If nobody else has any questions, I'll close the lecture session for today. Thank you very much, Dr. Raghuram. It's really fascinating, and the potential is really large, even though you may have to, for different products, you may have to change certain machines depending upon the kind of the input that is coming in. And it is also quite impressive in the sense that nothing is hand touched, in the sense of the safety of using all these blades and other things are taken care of by design. And
Yeah.
so thank you very much, and have a very good day, the rest of you, and bye.
Thank you so much. Thank you.